Okay, so now going through the solutions to these two. So this is the first one. So in this circuit, I'll go with yellow. So we've got a circuit here which has series and parallel components. So the first thing to do is figure out the total resistance. So 1, find R total. 2, find I total. Those two are always the same. And then 3, solve using the rules, Kirchhoff's current, Kirchhoff's voltage, and Ohm's law, as you can, okay? Now, the first thing to do is to find the total resistance. So the first thing we've got to do is figure out which part can we actually solve directly. Now, this 330 ohm is in parallel with both of these. So the first thing you've got to do is figure out this part, okay? So the series, I'll call it RS for series, is just going to be 120 plus 560, because those two are just purely in series with each other. And I haven't actually figured this one out yet, so I'll do this as I go. It's 680 ohms. That's the resistance of this branch there, okay? So then we need to find the resistance of the whole thing. Now, those two branches are in parallel, so it's going to be 1 over the total. It's going to be 1 over this branch, one we just figured out, 1 over 680, plus 1 over 330. Is 0.0045. So the total resistance is going to be 1 over that, 0.0045 is 222 ohms. Round it off a little bit. Okay, so that's the total resistance of the circuit. Okay, so the next step, so that's step 1. Step 2, like before, find the total current. I'll do it over here. Total current is the total voltage divided by the total resistance. So it's 12 volts divided by 222. Is 0.054 amps, which is 54 milliamps. All right, now we know that, we then can start solving things. Now, first thing I would look at this and think is, okay, we don't know the voltage across either of those resistors, like the 120 or the 560, but we do know that the voltage across the 330 ohm resistor is, changing color. I'll call this one here. I'll call this one V3. It's going to be 12 volts. Because in the outside loop here is the power supply and the 330 ohm resistor. Those are the only two things. There's the power supply giving 12 volts. The 330 ohm resistor must be using 3 volts. That's right, it must be using 12 volts. So we can calculate, actually, sorry, I'll just change color to something else. If I label some currents in here, I'll call this one I1, which we've just figured out, that's the total current, 0.054 amps. And we've got I2, which we don't know, and I3, which we don't know. Okay. But we can figure out I3 because we know the voltage and the resistance down here. So we know that I3 will be V3 over R3 using Ohm's law. So it's going to be 12.0 divided by 330. Which is 0.036 amps, 36 milliamps. Now that we know that, we can then we just look at, okay, what's the next thing we can find out? Now, in this case, because we already know I1, and we now know I3 is, what was that? 0.036 amps. So we know there's 0.054 amps coming into this junction. We know that 0.036 is going down here. The rest must be I2. So I2 is going to be I1 minus I3. So it's 0.054 minus 0.036. Is 0.018 amps, 18 milliamps. So 0.018 amps. Okay. So now we've got all of the currents figured out. Now we just need to find the voltages for the 120 and the 560 ohm resistor. But we know the current going through them. This I2, the 0.018 amps, goes through both of those. So if we've got, I'll call this one V1 and V2. So we can go V1, we can use Ohm's law. Is the current there is I2, and confusingly named. I'll call it I1. That's unfortunate, but anyway, we'll go with it. So it's going to be 0.018 is the current multiplied by 120 ohms. Is, I'm going to round it off a little bit, 2.2 volts. Okay, so V1 is 2.2 volts. Now, we've got one thing left to find, and it's V2. Now, we could do the same thing. We could use Ohm's law again, and you'd get the right answer. But I'm going to do it a different way just to show you the other way, and that's using Kirchhoff's voltage rule. In this loop at the top here, we've got a 12-volt supply. And we know that this 120 ohm resistor is using V1, so V2 will get whatever's left. Okay, so V2 is going to be Vs minus V1, so it's going to be 12.0 minus 2.2. Which is 9.8 volts. Okay, so you could have done that one, the last one there, using Ohm's law as well, and would have gotten the same answer. Okay, so that's that one. So I'll go through the other example now. This is, again, the same resistors, but arranged differently, okay? And we'll go through the same steps. If you haven't done this one already, pause it here and have a go at it first. But same steps. Hang on, I've just got the wrong color there. So step 1, find the total resistance. Step 2, find the total current. 3, solve using whatever you can. Kirchhoff's voltage, Kirchhoff's current, or Ohm's law. Okay. So I'm actually going to label some things here quickly, just to make it easier. I should have done it on the previous one to make it a little bit easier. I'll call this one V1, V2, V3, the 3 voltages, and I'll label some currents in a different color. I1 into this junction, and we'll have I2 and I3. And those all match up because, yeah, I1 goes through V1, and yeah, that's all good. All right, and while I'm at it, I may as well just label this one is R1, this one is R2, and this one is R3. All right, it's good when the numbers match up. So first thing is to find the total resistance. So now we have to pair this up. So first of all, we do the parallel section. So it's going to be 1 over 120 plus 1 over 560. Is 0.0101. But remember, that's parallel. 1 over 1. So the actual resistance of that parallel section is 1 over that, 0.0101. Is 99 ohms. I'm going to round it off to the nearest ohm. Okay. And then that is then in series with the 330 ohm resistor. So I then have to do that combined with that bit, okay? So the total resistance is going to be the parallel bit plus R1. So it's 99, which is the parallel bit, plus 330. So it's going to be 429 ohms. So that's the total resistance. Okay, so that's that bit. The next bit we need to do is find the current, the total current. Current is now blue, so we do this same way as always. Total voltage divided by the total resistance. So total voltage, 12 volts. It's not always 12 volts. I've used the same numbers in all these examples. Maybe I should have used some different ones, but we're there now. Divided by 429 is the total resistance in this case. So is 0.028 amps. Is 28 milliamps. Okay, now that we've done that, we now have to figure out what we can actually figure out. So we know I1 is 0.028 amps. So we now have to look at what can we now figure out. Okay. Now in the last one we looked at, we knew that there was a voltage we knew, but in this case we don't, because these are both in each loop there are two things. Like in this top loop there's the power supply, the 120 ohm resistor, and the 330 ohm resistor. In the outside loop there's the power supply, the 560 and the 330. So none of those are going to be 12 volts. They're all going to be sharing the voltage with something. So we can't use that, but what we do know is that this current I1 goes through this resistor R1. All of the current goes through resistor 1. So we can find V1 using Ohm's law. I1, R1. Okay? So because all of the current goes through that resistor at the top. So it's 0.028 amps multiplied by the resistance 330. Is 9.2 volts. So this one is 9.2 volts. Okay. And then we look at, okay, what else can we figure out? Now we've got two currents that we don't know and two voltages that we don't know. Now the next thing we can do is we can figure out the other voltages. Actually, we can figure them kind of both out together, because the thing with V2 and V3, anything's in parallel will have the same voltage. But let's just look at this loop at the top. I'll draw it on here, the loop that goes around here, this loop here. We've got 12 volts being put in here. V1 has got 9.2 volts, and we've got V2. That must be using the rest of the voltage. Okay, so we can use Kirchhoff's voltage rule. V2 will be the supply voltage minus V1. So it's going to be 12.0 volts minus 9.2 volts. It's 2.8 volts. Now, we could do the same thing around the outside loop. But look, if we do around the outside loop, we've actually got exactly the same argument. We go around the outside, we've got a 12 volt supply, we've got V3, and we've got V1. So you can actually do that. You actually end up with exactly the same thing. But the other way of looking at it is that V2 and V3 are in parallel. Any things that are in parallel must have the same voltage. So V3 has to equal V2, which is 2.8 volts. Or you could do the same calculation again and you get the same answer. Okay, so we know that these two are both 2.8 volts. All right, so we know all the voltages. We're now left with two currents to find. So if we look at I2, we know for this resistor, we know the resistance and we know the voltage. So we can use Ohm's law. So we can go I2 is V2 over R2. So it's 2.8 volts divided by 120 ohms. It's 0.023 amps, 23 milliamps. Now, we know that one, so I2 is 0.023 amps. Just leaves us with I3. Now we could do the same thing. We could do the same calculation. We could do Ohm's law again and you'd get the correct answer. But there's another way of doing it. I'll show you the other way. It's looking at this junction, okay? We know that the total current is I1 and that I2 is taking some of the current and the rest must be I3, okay? So the total current was 0.028 and I2 is 0.023 and whatever's left over must be I3, 0.005 amps, 5 milliamps, 0.005 amps. So that's how you go about solving circuits, okay? Those first two steps are always the same. Find the total resistance, then find the total current using Ohm's law, and then you have to use Kirchhoff's voltage rule, Kirchhoff's current rule, and Ohm's law as you can, okay, to solve for the rest of the things in the circuit.